Hi and welcome to another ICOM story. Yes, here on my bench, an ICOM IC-7000. And yeah, we have a radio which came in with no transmit on all channels and all modes, so nothing. And as we see, we are in the RF power setting, and power is set to 100%, so that really means full RF power is set here at our radio. Now let's see what we can see on our watt meter. Alright, everything is prepared. Radio is set to FM, so that we have a solid carrier. And yeah, let's see what we get. So there is definitely no sign of output power. Also our takes LED on the radio is switching on, so that means that yes, our radio is switching to transmit. That is fine. What we always do is we check if there is a rest carrier to see on our scope, and yeah, as I said, radio is set to FM. It is set to full RF power, and so let's see if we can recognize something, and yes, we do. So important here is first of all we see a sign which is our carrier, but more important is the frequency we can read here. Okay, let me see if you can see it. Alright, so there in the right upper corner, up there, you can read our frequency, which is 14.195 megahertz. So that means radio is transmitting on ham radio band. And when we go back here to the radio, we see our radio is set to 14.195 megahertz. And we see our transmit LED, so that all is nice, no problem whatsoever. And that we see our 14.195 megahertz on our scope means that obviously the PLL and so the complete frequency generation here in the radio is fine, but we do not get our output power, so what we see on the scope is only a fraction of the power. So that could mean that we have here a driver problem. If you have seen earlier videos here on my channel, you have seen that we had a couple of IC-7000 here on my bench, and they were suffering from the known driver problem. So the IC-7000 is known for burnt out driver stages. So that could be that we have here another radio with a broken, burnt driver stage. So let's take the radio apart and let's see if our assumption is right, or if it is something different, what of course could be as well. And if you have seen my earlier videos, you know that this here is our final board with our final transistors, and that we have our driver board down here. So I know I have to say that we can't see anything so far, so that is not possible from the view we have from the side. But what I can tell you is that it is really smelling burnt, I would say. So something has happened here in this area. So I believe that our assumption is not too wrong. Okay, so there is one point I want to check before we go ahead, and that is if our supply voltage is getting here to our driver stage. And as we can see, yes, our power supply is working and delivering here the power to our driver board. And now, after knowing that that is working, we really have to go ahead, and we really have to take it apart. And again, if you know my earlier video on this subject, you may know that it is really a lot of work to get it all apart here, and to get the main power amplifier out, because that is absolutely necessary to get down to our board here. So I don't explain it step by step, because as I said, there are earlier videos on a similar subject already on my channel. So simply let me take the board out so that we get access to our preamplifier, and then we see what we have. Okay, and as you can see, I lifted here our PA board, filter board up a little bit, so that we are able to get access to our driver. And when I'm zooming in, you might already see it. It is for sure a burnt driver stage. So you see here, this area is completely carbonized, so that is really a clear sign for the fact that yeah, our pre-driver is broken. Okay, so let me get out here our pre-driver board to investigate it a little bit more in detail, because for us it is now very important that we can still use our board, because, and that is what I haven't told you yet, this radio has been at ICOM, and they said, oh, we can't repair it, so we do not have these boards any longer. Okay, so you know, that is a MOSFET transistor which is on this board, and there is no reason to swap out the defective field effect transistor to make it working. But they are stating, no, we do not have this little pre-driver board, we can't repair it, it is end of service. And yeah, okay, so let me see if we can still use this board, and if it is not too much damaged, then we can of course install a new MOSFET to this little PCB. Okay, and watch this. So now I lift it up, and there is not only a bit grease here on you know, here on the chassis, or here on the heatsink, so that we have here the heat component, which is needed from my point of view to get a good heat transfer here to the chassis. and that is not the first time I have seen it, and really, you know, that is a shame. And here as well you can clearly see the burning marks, so that is definitely one of our typical problems which we have with all the IC-7000. So that is not the first one, and it is definitely not the last one which I will see here on my bench. And I mean, even now, where ICOM is stating that they do not have any longer here these little boards, which is really fun. It is a joke. And when we look here at the MOSFET, so it really looks like that the MOSFET was boiling and burning, I don't know. So it is very obvious. Interesting point is that this here is already the board with the modification. So we do have here this little transistor, which is a second batch or board after modification, because ICOM of course know about the problem, and they have known about it very, very early. And the first boards, and that is what you can see as well on my earlier videos, so this resistor was not there on the first boards, and they added it simply to reduce the risk for this burning here. But as I said earlier in an earlier video, this is not 100% sure, safe. I mean, it will reduce the risk that it happens, but this alone can't completely avoid that this is happening to our driver board. Okay, but it looks like from the first, really from the first look, it looks like that we can use it once again. So now it is important to get here our transistor off this little board, and then let's see how it looks like afterwards. Alright, so I would say we saved the board. I mean, of course, we see signs that, you know, the board has suffered. So, for instance, here where it really was carbonized, so you see that we have here damaged on our copper layer. So I mean, we need to improve this connection, because that is here, if you will, the output. So that is the drain of our MOSFET, and alright, that is the source here, and so that is the gate. So I mean, all the other connections are more or less nice without a problem. I mean, this is the one where we need to do a little bit, but that is not the end of the world, because worst case we can bend this here. I mean, I have already cut it here a little bit to the edge, and if we need, we can bend it over and we solder it then onto our MOSFET connection over there. And then, of course, additional to that, we have here the integrated heatsink, which needs to go back here to the back side, so that needs to get soldered to the board as well. So you see we need here the solder connection with our new MOSFET, and then we bring back here our resistor, which I've taken out for you know, all the soldering I've done. And I mean, yeah, so that is not, yeah, it is not so easy. You really have to be very carefully not to damage the board and the connectors and what have we. So yeah, okay, be careful. That is a little bit critical. And here we have already our new MOSFET, which we will solder on our PCB. And then I'm quite confident that we can bring it back to normal working condition. As you can see, our heatsink is already back on. So now our next step is to bring back here our MOSFET. Okay, so our new MOSFET is in. Would be almost perfect if we would not have had here this damaged area. So yeah, I needed here to rebuild a little bit the lost copper, but I believe it looks good, and yeah, we can really use it that way. Now I have to put back here our resistor, and then I can put it back into the radio. Okay, and here on the PA board we have, yeah, let me zoom in a little bit. So we have here our pre-drivers, right? And we know from the past that these pre-drivers are getting quite hot under heavy working condition. And you know, if these pre-drivers are really hot, that means that they develop a tendency to a kind of self-oscillation, and that is also known as you know, the killer for our driver, so that they start to burn out, because this heavy self-oscillation makes or brings up the problem for the driver, and therefore we install here to our pre-driver, you know, extra little heat sinks to, yeah, keep finally the temperature under control here at our pre-drivers, to protect at least our driver stage from burning out. So that is what we know from the past, that that was really helpful, and therefore, yeah, so let us do that to make it as good as possible, as we have seen that here our additional resistor, which is already the modification, does not always help, because otherwise this board never would have been burned out. Okay, and now you see here at the pre-driver and the pre-driver our little heat sinks directly connected here to our that are FETs as well. So now they get a better cooling, and so we can prevent them from self-oscillation when they are getting hotter. Okay, now next is to bring back our pre-driver board here into the chassis. And of course, before we go ahead, we put now thermal compound here to the location of our driver to make sure that we have an effective heat transfer to the chassis. So I do really not understand why that has not been done in the factory. I mean, all the other transistors, like here the finals, are having the thermal compound, but not the pre-driver, and really I don't understand it. Anyways, now it is done. And our pre-driver board is in, not pre-driver, or driver board is in, and we can go ahead. Alright, and all is back together. I mean, as I already said earlier, so there are more than only one IC-7000 here on my channel. So there it is much more detailed. This one is only the new things we do with the additional heat sinks for the pre-driver, right? What we have done, and you have seen that even a board with the modification where we all thought that that will help for its own can blow as well. So this radio is really critical, and I really had quite a lot on the bench with exactly the same failure. And you know, that is a kind of embarrassing for ICOM. I mean, that is an A brand, so-called, and you see what's happening. Okay. Everything is back, so radio is connected to our power supply, and let's go right into the testing. Okay, so that is fine, as you can hear. And now, of course, we are interested in is a power amplifier working? So, okay, let's say we go here to 15% for our first test. Okay, and now we want to see what is here happening with 15%. Radio set to AM so that we have a continuous carrier, and let's see. Wow. And radio is definitely back working, so let's increase it here a little bit more. And so I'm wondering what is 100 and 125. So, and that can be the reason for the faulty or burned out driver as well. So it looks like that the radio has been turned up. So with 100% here on our RF indicator, output indicator, you see we are able to push for 124 watt. And that is something what I always say, it does not make a lot of sense, because you really stress radios like this. You know, it is a small radio, that means we have only small heatsink. So the heatsink is a chassis itself, and the heat has to dissipate somewhere. And if you crank it up to more than 100 watt, it is always a risk that you really toast your radio, and I never recommend it. I always put radio like this to 90 watt, but well, it is up to the owner. I would not do that. Anyways, we leave it, and if somebody has cranked it up, he can now afterwards decide if he likes to put it down, or if you want to leave it at 125 watt. So at 80 watt, not 80 watt, 80%, which should be 80 watt on the other hand, what will be the output? It is 95 watt. So I would definitely the radio leave at 80%. I would not crank it up any longer or anymore, because yeah, you see these radios are dying, and sometimes it is not only the fault of the manufacturer, it is also the fault of all you know, the operators who really want to get the last watt out of the radio. Anyways, that's it for today. I hope you get some new information, and you see you can repair a driver board even if ICOM is not delivering the whole board. I mean, yes, it is a lot of work, and you need the right equipment for sure. You need a little bit experience, so don't think it is too easy. Because you have seen we have on the little driver board a heatsink as well, and you need to put your new MOSFET onto the heatsink, and you need to solder the MOSFET to the heatsink, and you know that that is not always a very easy task. And you see, additional to that, if you have a burned out driver, then you definitely have you know, the board is somewhat burnt as well, and therefore it is even more difficult to do it. So I just want to warn you, it is not that easy. Anyways, this radio is ready to go, and thanks for watching, and catch you next time. Bye.